Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Count servers that communicate. Leetcode 1267. In this problem, we are given map of server center represented as a m into n integer matrix called grid, where 1 means that on that cell there is a server and 0 means that there is no server. Two servers are said to communicate if they are on the same row or on the same column. And we should return the number of servers that communicate with any other server. Then in example 1, we are given 2 by 2 grid. So this is row 0, this is row 1, this is column 0, this is column 1. And we have two servers, one on cell 00 and another on cell 11. This server does not have any server on its row or on its column, so it cannot communicate. Similarly, this server also doesn't have any other server on its row or column, so this server can also not communicate. So because of this, total number of servers that can communicate will stay 0. Then in example 2, again we are given 2 by 2 grid. This is row 0 and this is row 1. This is column 0 and column 1. Now this first server doesn't have another server in its row, but it does have a server in its column. And for a server to communicate, it needs at least one more server in either the same row or column. Therefore, we can mark this server as a communicating one. Then for this server in cell 1, 0, it does have another server in the same row and also in the same column. So this server can communicate with any of these servers, and we can mark this server as communicating one as well. And finally, for this server, it does have one server in the row with which it can communicate. Even though there is no server in the same column and the servers cannot communicate diagonally, so this diagonal server is irrelevant. Therefore, we can mark this server as communicating one as well. And in the end, the total number of communicating servers will become 3. And that will be our answer. Now let's take slightly bigger example. We are given 4 by 4 grid. So again, we will go through the servers, and this server does have another server in the same row, which is this one. So this is a communicating one. Similarly, this server also has another server in the same row. So this server can also communicate. Now we come to server number 3. And this server has another server in the same column. So this is a communicating one. And this server also have another server in the same column. So this is also a communicating one. And finally, for this server does not have any server in the same row or same column. So that's why it is not a communicating one. So total number of communicating servers are 4. Now in terms of solution, one of the naive approach can be to iterate through the grid to find each server. That is, we go through each cell in the grid to check if it contains a server. For example, we found this server. And then for each server, we will scan through its entire row and column to see if we find another server. If we do, then we will mark the current server as communicative one and increment our answer count. Otherwise, we will continue with our iteration. And the time complexity of this approach will be O of m into n plus m because of the nested loops to find the server. And then for each server, we go through n cells in the row and m cells in the column to find another server. So because of this, the overall time complexity is O of m into n plus m. And now the question is, how can we do better? Can we do some kind of pre-processing to help us with the runtime? And the answer is yes. We can use a hash map or simply a frequency table to achieve this. For a server in a given row, we need to find if there is at least one more server in the same row. If there is, then the server can communicate. Similarly, for a server in the given column, we need to find if there is at least one more server in the same column. If yes, then the server can communicate. So that means for each server, if number of servers in its row or column are greater than 1 or greater than or equal to 2, then the server can communicate. Otherwise, it cannot. So how about we create two arrays, row counts and column counts, to store the number of servers in each row and column respectively. So we create row counts of size m and column counts of size n. And now in the first pass, we can go through the grid and do the pre-processing. So we will count the number of servers in each row and column. Whenever we find a server in the ith row and jth column, then we will increment the count for ith row and jth column in the row counts and column counts arrays. So let's see this in action. At position 0, 0 in the matrix, we see a server. So we increment the row count by 1 and also the column count by 1. Then at position 0, 1, we again see a server. So we increment the number of servers for row 0 to 2 and number of server in column 1 becomes 1. Similarly, we will continue with the grid traversal and find this server. So we increment the number of servers in this row to 1 and this column also to 1. Then we come to this server and now we increment the number of servers in this row to 1 and this column to 2. And finally, for the last server, we increment the number of servers in the third row and column as 1. So this completes our first pass. Now in the second pass, we will go through the grid again and determine if each server can communicate based on these row counts and column counts. That is, if either of row counts or column counts is more than 1, it means there are at least 2 servers in the current row or column. Hence, this server can communicate. So again, we will iterate through the grid. So first server we see is at cell position 0, 0. And for this server, there are 2 servers in the row. So this server can communicate. So number of servers that can communicate becomes 1. Then we come to server at position 0, 1. And again, this server has 2 servers in the same row. So number of communicating servers becomes 2. Then we come to this server. And for this server, number of servers in the row are 1. But number of servers in column is 2. So that means it can communicate in the column. So number of communicating servers become 3. Then we come to server at position 2, 2. And this server also has 2 servers in the same column. So because of this, this is also a communicating server and number of communicating servers become 4. And finally, we come to last server, which only has 1 server in its row and column. So that means this server cannot communicate. So because of this, our answer will be equal to 4. And now the time complexity reduces to O of m into n because we will go through this grid twice. Once for building this row counts and column counts and second time to actually count the number of communicating servers. And in terms of space complexity, it will be O of m plus n for storing row and column counts arrays. Now let's jump into the code part. First, let's get number of rows and columns in the grid as m and n and create an integer array row counts of size m and column counts of size n to store the number of servers in each row and column respectively. Now we will perform the first pass and iterate through the grid. And for each cell, we will check if the current cell contains a server, that is value is equal to 1. If that is the case, then we will increment the count of servers in ith row and jth column in row counts and column counts respectively. Now we are done with the first pass, so let's create our answer, which will store the count of servers that can communicate. Again, we will iterate through the grid. And again, we check if current cell contains a server. If yes, then we check if either of the row count or column count for the ith row or jth column is greater than 1. If it is, then we will increment our answer by 1. And once we are done with the iteration, we will return our answer. Now let's submit this code. Cool. Now as a follow-up, suppose the interviewer says that the matrix is sparse and the servers in the grid are sparsely located. Then how can we optimize our code? In that case, asymptotically, we can't improve the time complexity beyond O of m into n because we need to scan the entire grid to count the servers. However, we can optimize the second pass by storing the coordinates of the servers in a separate data structure like a list. And then in the second pass, instead of iterating on the grid, we iterate through the coordinates in this list. This reduces the actual number of cells we have to examine, although the time complexity remains O of m into n. So that's all for this video. Thanks for bearing with me as I have a sore throat today, but I hope the audio quality was not too bad. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.